on this topic, on this paper, which is November 2021, paper 3, okay, for Edexcel. So question 7 then, it says the diagram shows a sector of sector OPQR of a circle with a center O and a radius of 8. OPR is a triangle. Work out the area of the shaded segment PQR. Give your answer correct to 3 significant figures. Okay, so I think the way to do this is to first of all find the area of the whole sector, which is a quarter of a circle, and we can tell that because we've got a right angle there. So we're going to do 360 degrees divided by 4, or we could write it as 90 over 360. But either way, it's a quarter of a full circle, and a full circle is pi times the radius squared. So 90 over 360 times pi times 8 squared. So the area of that full sector is 50.265 centimeters squared. Now, let's work out the area of the triangle. The area of the triangle is just a half base times height. So a half times 8, which is 32. So therefore, the area of the segment is the area of the sector minus the triangle. That gives us the segment, the one that looks a bit like a Terry's chocolate orange kind of thing that you get at Christmas. So area of a segment is 50.265 minus 32. That is 18.3. And that is question 7 done. Okay, now question 8. Using the axes below, sketch a graph to represent something that is directly proportional. Okay, so directly proportional is just going to be a straight line going through the origin. Okay, it doesn't really matter about the gradient. The gradient would just depend on whether there was a different value of k in there. Inversely proportional, if something is inversely proportional, then y is proportional to 1 over x, and the graph of y equals 1 over x looks like that. So in the portion that we've got, it's just going to be that kind of a curve, looking something like that. So that's all we would need to do for question 8. Question 9 then. Okay, this is a inverse proportion question. So it says that on Monday, kind of a classic kind of question, on Monday, 12 people took 5 hours to clean a certain number of cars. On Tuesday, 15 people cleaned the same number of cars. Assuming that all of the people worked at the same rate, work out how many hours 15 people took to clean the cars. So the first step in these kind of questions is always to work out the number of hours of labor that's required to complete the task. And 12 people took 5 hours. So that means 12 times 5 means that 60 hours of labor was required to complete the task. So we then divide that by 15 because we've got 15 people working. So a task that requires 60 hours of labor divided by 15 people means it's going to be completed in 4 hours. Now it says the assumption is wrong, the assumption being that all of the people worked at the same rate. How might this affect the time taken for the 15 people to clean their cars? Well, we don't know really, because all we know is that the assumption is wrong. So it might be that they all worked slower than was imagined, in which case it could take more time. Or maybe they all worked faster, in which case it could take less time. Maybe some of them work slower and some of them work faster. So really, it's kind of like hard to tell really, but you could just write down, it might take more time or it might take less time. But either one of those would be fine. Question 10 then, it says a diagram shows 2 right angle triangles ACB and DEB. And it says we're given these facts that AD is 9, that DE is 6, and that, DB is 6, and that DE is 2. And we're going to calculate the length of CB, so the length of that whole that side there along the bottom. Now, I think the thing that really helps in this kind of question is to recognize that what we've got essentially is 2 triangles inside each other. So if we can like separate the 2 triangles, we've got one here and one here. And you can see that, let's label this. So this is triangle A, that is B, and that is C, and that is D, and that is E, and that is B. Okay, so this length here, AB, is 9 add 6. So that is 15 along there. Okay, so they're similar triangles because they've all got the same angles. So the angles are the same in all of them, so they are similar. So step one is to work out the scale factor of enlargement, okay? Now the scale factor of enlargement is going to be given by dividing the long side by the corresponding short side. So in this case, the 9 add 6, okay, 15 divided by 6. That's our scale factor. That's what you'd have to times by to go from the small triangle to the big triangle. In this triangle, we can work out the length of EB using Pythagoras' theorem. Okay, so using Pythagoras' theorem, we can work out that length, and that is going to be 6 squared take away 2 squared gives us equal to root 36 take away 4, so root 32. So that length is root 32. So in order to find out the longer side that we need, it's going to be the root 32 times by the scale factor. So we times that together, and that gives us 14.14. So the answer there for question 10 is 14.14. Okay, let's see. I'm going to do that one in, well, I'll carry on in the next video, I think.